no,
Okay.
the swings are kicking in.
You should have the note sheet out in front of you. So today, what we are going to be reviewing are things that we've covered in 6th grade. So today's lesson is going to be dealing with simplifying algebraic expressions. Now they're algebraic because they have, thank you dear, they're algebraic because they have variables, they have operations, and they have numbers. So we're going to talk today how we simplify those to make our lives a little easier. Now, we've already discussed this to some extent already in the past couple weeks, so this shouldn't be something completely foreign. The first thing we're going to look at is up at the top. It discusses the distributive property. Now, this is definitely something that you covered in 6th grade. Yes, because I covered it a couple weeks ago with my 6th graders. So you for sure covered this in 6th grade. Now, whether or not you remember it is another story. Now, how many of you, raise your hand if you've heard the word distribute? Okay, keep it up if you could tell me where you've heard it or what you think it means. What do you think, Hannah?
I heard it in social studies, like the distribute of goods.
The distributing of goods? Absolutely. Where else have we heard it? Rick?
One time I went to my grandpa's house and he said, let's distribute some money to the kids.
Absolutely, distributing. So what did that mean? When he said he was going to distribute money to the kids, what did that mean?
Give it to us.
Yeah, to distribute means you're giving something out. So if you're distributing goods, you're giving out goods, depending on what that would be. Evan, what are we doing right now?
I'm looking at this water bottle.
What are we doing right now? Try again.
Looking at this water bottle.
Stealing it off of Lexi's desk and being a distraction is what I saw.
Okay.
What happens when that happens?
RTC.
Is that what we want to do today? Okay. My suggestion is put your back in the back of the chair, which will help you stay a little more focused.
No, I can't see you. Because then I'll be like this.
Does your head? Look at that, your head moves. Phenomenal, isn't it? All right, so in the math sense, what it means to distribute is you're going to give one number to other numbers. And giving, in a sense, is multiplying here. So, for example, if I look at number 1, I'm going to zoom way in. I have 6 times a plus 4. Now, raise your hand if you can tell me, why don't I add the a and the 4 together? Why can't I do that? So think about it for a second, and then when you've got your idea, go ahead and raise your hand. I'll give you about 10 seconds to think and get your hand up. Why can I not add the a and the 4 together? You need a packet too. It's back there. Brady, what do you think? Why can't I add the a and the 4 together?
Because the a is a variable and you can't add variable stuff.
Lexi.
You know what it is.
Take that to the same table. Say that one more time for me, Brady.
Because the a is a variable and you can't really add variables to things because you don't know what they are.
Right. We can't add variables and numbers because they're not like terms. You can't just combine them. So you're absolutely right. So what we're going to do is distribute this 6 to everything inside the parentheses. So I'm going to do 6 times a, which you just smush them together, so it's 6a. And then I'm going to do the 6 times the 4. Now here's the tricky part, or here's the kicker. You want to make sure that you multiply the sign in front of it as well. So this is not just 4, but is it a positive or a negative 4? It is
Positive.
It's a positive 4. So 6 times a positive 4 gives me a positive or negative 24?
Positive.
Positive. So I would write plus or positive 24. Take the sign in front and use that as part of the number. Eric, you should be writing this down. Jody, write this down. So if I look over here now, negative 3 times the quantity of x plus 2. So if I multiply times both of those, so I'm going to do negative 3 times x, so that's negative 3x. Now remember, I take the sign in front of the 2. So negative 3 times a positive 2 is...
Negative 6.
Negative.
What's 3 times 2?
Negative
6. Is it positive or negative?
Negative.
So I do negative 6. Hi, Mrs. D. How's it going? Good.
I just noticed this.
Oh yeah. It's getting a little bigger. by day. Thanks. Thanks. Yes,
Would
Samantha.
it be plus negative 6?
Okay, that you could write that as well, because remember, subtracting is the same as adding the opposite. So you could write it as negative 3x minus 6, or you could write it as negative 3x plus a negative 6. It's the same thing. It means the exact same thing. So what Samantha is saying is, hey, could I leave the sign? So I do negative 3x. I would not take the sign, but I do negative 3 times just this 2, and it would be a negative 6. That's also acceptable. Why? Subtraction is the same as adding the what?
Opposite.
The opposite. Well, if I change this to adding the opposite, that would be plus a negative 6. Now for my brain, it's easier to take the sign in front, so that's what I'm going to continue to do. If that doesn't work for you though, and you like the way below, that's fine. Again, we all process things differently, whatever works for you. So number 3 now, I've got 4 times x minus 10. So I'm going to do 4 times the x, 4 times the negative 10. So 4 times x is what?
4x.
4x. And 4 times negative 10 is going to be a positive or negative 40?
Negative
40. So this would be my solution. Now let me see if I can trip you up at all. What if I did, I'll write it down here, x minus 4 times negative 2. What do you notice is different about this? Evan, what's different? Okay, there's 2 sets of parentheses now, absolutely. And yeah, and now we've got, instead of the number being in front, it's after this quantity. It's after the things being subtracted. Do you think anything's different? No. You still have to multiply everything on the inside by what's on the outside. So I'm going to do 2 times x, and then 2 times this negative 4. So negative 2 times x is negative 2x. Negative 2 times negative 4 is a positive 8. Okay? I know I split it, but I'll fix it when you guys, excuse me. Questions at all about this? Okay, now if you look at your packet, the 10-1 study guide and intervention sheet, I guess I'm going to have to change this earlier than I thought. Okay, you will notice that problems 1 through 3 ask you to use the distributive property to rewrite each expression. I'm going to put a minute and 10 seconds on the timer, and I would like for you to use a distributive property to rewrite those. Okay, so I'll come around and make sure we're on the right path.
I realized I wrote my name for calculator, but didn't actually ever take
You
a
should
cut.
definitely get one of those. There's one on my desktop, but you can use that one. Okay, and then if you're done before time is, you hear the buzzer go off, just put your pencil down, because then if everybody's pencil's down, I know I can move on. That's correct, it would be plus 12. So let's look here. Number 1. 2c, or 2 times c plus 6. So Caroline, what'd you end up with for number 1?
2c plus 12.
Very good. 2 times c is 2c. 2 times 12, or 6 is a positive 12. Excellent. What about number 2? Gabe, what do you think that would be? negative 4w, because negative 4 times w is negative 4w, okay? Yep, and then negative 4 times 6 is a minus 24. So it's negative 4w minus 24. This last one I think caught a couple people, okay? Anybody want to be brave enough to, got some brave souls that want to try to explain what they did? Kylie, go for it, kiddo.
I did like negative 3 and b.
Right, so that would be negative 3b.
And then I also did like plus 12 because like negative 3 times negative 4 is a positive 12.
Perfect. So we've got this negative 4 here and this negative 3. Negative times a negative is a positive. So this would be plus 12. Kylie, that was fantastic. Awesome job, kiddo. So a lot of us had that minus 12, but we weren't really paying attention to those negatives. So just be careful, okay? Quick, just fist of 4, how we feel about this. Okay, so it looks like we could use a little more practice with the distributive property. So here's what I'd like you to do. Turn the page to the 10-1 skills page. So it's just one away. And you'll notice at the top, listen, there's a ton of problems dealing with algebraic expressions. What I would like is, again, we're going to walk through these one at a time a little better. Break it down a little more just to make sure. What I'd like us to do is we're going to start with number 2. And I'm only going to give you 30 seconds to do that. So what I want you to do is take 30 seconds to solve number 2 on the practice skills page. Good. And when you're done, put your pencil down.
No, it's not my pencil, so I don't need
Good. All right, 30 seconds may have been a bit too long, but if I'm multiplying 5 times n and 5 times 2, 5 times n is what, everyone? 5n. 5n. 5 times 2 is?
10.
Plus 10.
Whoa.
Okay, we're going to do one more. We're going to make it a little harder.
Uh-oh.
Okay, let's try number 14. Number 14. So I'm going to give you about 20 seconds this time because it did not take us 30 seconds the last time. Yeah.
Damien's never like mine.
Okay. All right. So looking up here. Excuse me. Isaiah, walk me through number 14.
Okay. So I did 9 times 2b first,
Okay.
which would be 18b,
What kind of 18?
negative.
Okay. Then what?
And then I did 9 times 3, which would be a positive 27 because they're both negatives.
Very good. So we should have negative 18b plus 27. Now, after a couple more, how are we feeling? Fist of 4. We feeling a little better? Good. Okay, so again, we're going to continue to practice with this, but right now we're going to move on. So you can go ahead and turn back to the front page of your packet. All right, and then we're going to start talking about different parts of an expression. Now, I will tell you, this is review. You also did this in 6th grade. Now, how deep we got into these concepts is another story. We definitely skimmed the surface. So we are going to look at an expression, we're going to examine it, and then we are going to talk about the different parts of it. So, the first part of an expression are the terms. The terms of an expression are the parts of an expression that are added together. Now, the reason they don't say added and subtracted is because any type of subtraction, we've talked about this many, many times, can be turned into addition. Because subtraction is the same as adding the opposite. So the example I'll give you, we'll write down an expression. We'll do 5x plus 6y plus 2 minus 4x plus 6. Okay, so there's your expression. Yes, it's a lot of stuff. But we're not doing anything with it. We're just looking at the parts. Now, the parts of an expression are all of the things, again, like I said, are that are being added together. What do you notice here? Is there some subtraction? Yeah. So what do we do with that? How do we determine terms? Well, let's start out from the top here. This 5x is being added to 6y. So one term is going to be 5x. The other term is 6y. Then I'm adding this 2. So 2 is another term. Now, with this 4x, it's not being added. But could I change that subtraction to addition so that it would be adding? Yeah. Well, if I'm subtracting 4x, that's the same as adding a negative 4x. So my term is just negative 4x. So you don't actually have to change that to addition. You just take the sign with the number in the variable. That's all. And then your other term is going to be 6. That's it.
Too easy.
Yeah, this is one of those things where you're going to look at it and go, that's all I have to do? Yes, this is all you have to do. Now, to specify that even more, we don't just have terms, we also have like terms, which is something we've already discussed. Evan, you want to take a stab at what like terms are? What are they?
So 5x and 4x.
Okay, so you're saying here the like terms would be 5x and negative 4x. Right, now if I were to write a definition about those, why are those like terms?
Because they have the same variable.
They have the same variable attached. So like terms are terms that have the same variable attached. Or, there's another example of like terms we've talked about. Ooh, Evan understands these like terms. What's the example? What's the other part?
The one with no variable.
Yeah, if they both have no variable, we can add them together, right? The numbers 2 and 2, neither one of them have variables, but do we know how to add those together? Yes, absolutely. So they're the terms that have the same variable attached, or neither has a variable. So I'm going to now write down that expression one more time over here. So I've got 5x plus 6y plus 2 minus 4x plus 6. Now I have to identify my like terms. So my like terms, again, they have the same variable or the same letter attached. So Evan already told us, Evan, what are the letters that are the same? Excuse me.
5x and 4x.
What kind of 4x? Yes. So my first set of like terms is 5x and negative 4x. Perfect. Is there another set of like terms? Lexi, what are they?
6 and 2,
Right. Why 6 and 2?
because they know that neither of them have a variable.
Right, because neither one of them have a variable. So since neither have a variable, those are like terms. We could combine those. I could add 6 and 2 together. I mean, I hope we could add 6 and 2 together, but I guess it's, 2 days before spring break. Maybe not.
Wouldn't that just be 2x?
This one up here?
It's 62.
it would be 5x and negative 4x. So if I have 5 x's, Tyler, I'm taking 4 away, how many x's am I left with?
One month.
That would be just
No,
1x.
no.
But if I combine 6 and 2, I'm going to have,
62.
nice try. 6 and 2, or sorry, 6 and
62,
2.
62. I just realized what he said.
All right? Okay, there's a couple more things we need to discuss. Coefficients and constants. Coefficients, again, I touched on this last week, but again, we probably need to review it. Coefficients are the numbers that are in front of the variable. Okay, or in other words, it's the number attached to the variable. So it's a number. So again, if I write down my same expression, 5x plus 6y plus 2 minus 4x plus 6. So if I'm looking to identify coefficients, I am only looking at the numbers with variables. That's it. So if I look at my first x, the number that is in front of it is 5. That is the coefficient. So my first coefficient is 5. The number in front of y, 6. So my next coefficient is 6. My number in front of negative 4x is what?
Negative 4.
Negative 4. So my coefficient is negative 4.
But 2 and 6 are not.
Right. Those actually have, because those don't have a variable. And those numbers without variables have a name. Anybody know what those are?
Numbers.
Yes, they are numbers. Starts with a C. What is it?
Constants.
They're constants. Very good. So the last row should say a constant is a term without a variable attached. Are we writing this down?
Yeah.
That would probably be part of our problem right now. Yes.
Well, I was looking at the paper and it said locality term, and then it says term again.
That it does. All right, now, again, if I write this all down again, 5x plus 6y plus 2 minus 4x plus 6. So my numbers without my variables attached, my constants. Everyone, what's the first one? 2. 2, and the second is? 6. Excellent. Now, given an expression, give it back.
Didn't notice.
What happens when we're taking people's water bottles in the middle of instruction?
Sam, take your
Isaiah, what happens?
We go to RTC.
Is that what we want to do today?
No.
Okay,
It was smooth, too.
thank you. So if we turn the page, there's a lot of examples that are going to help us do this. So again, I'm going to show you how this works. Up at the top, it says, given the expression below, identify the terms, like terms, coefficients, constants. I'm going to walk us through one, and then I want you to try one on your own. Excuse me, okay? So it's 8x plus x minus 5 minus 9x plus 2. So my terms are all those things being added together. So it's just easiest if you write them down from left to right. So I've got 8x, I have x, negative 5, negative 9x, and 2. Those are all of my terms. Tyler, do you have a question?
Yeah, we did this last year. We had to do it on the test.
Right, remember I already mentioned that earlier. I said this is review. Now my like terms again are the ones with the same variables attached. So I have 8x, x, and negative 9x all go together. I also have 2 and negative 5 that go together. My coefficients are any numbers in front of my variables. Now, that doesn't mean it's the numbers in front of the like terms. You might have variables that aren't like terms. That,
Is terms all of them?
yes, terms is all of them.
Okay.
You may have like terms, or you may have variables that don't have like terms, but they still have coefficients, so you got to pay attention to that. So always go back to this original expression. So coefficient here is going to be 8. What's the coefficient here?
1.
Okay, thank you. And then negative 9. And my constants are negative 5 and 2. Now here's what I'd like. I again would like to give us about another minute and a half. What I'd like for you to do is if we look down on the page, you'll notice there's another expression. And there's the list of terms, like terms, coefficients, and constants. What I want you to do is just to take a minute, minute and a half, try this on your own. Okay, see what you can identify on your own using the definitions that we have. Okay?
So,
Time has started. Let's see where we're at. Remember to pay attention to the sign that is in front of your term. Excuse me. Bless you. All right. So timer hasn't gone off, but I think the majority of us are done. So, Sam, what would your terms be?
2G,
Okay?
negative 3,
Okay?
11,
Okay?
and negative 2G.
Awesome. Okay? What about our like terms? Tyler, what are our like terms?
2G,
Okay.
negative 2G,
Okay?
and 3, negative 3, and 11.
Very good.
Oh yeah.
Awesome. Callie, what about your coefficients?
2 and negative 2.
Very good. It would be 2 and negative 2. And Kenny, how about my constants?
Negative 3 and 11.
Very good. Now, before I go on to this last problem, fist of 4 was just that problem. Checking your answers, I got all of them right. That'd be a 4. I've got this down. 3 would be I could maybe use a little more practice. I did it right, but I could use more practice. 2 would be I got about half it right. I still have made some mistakes, and 1 is I'm really lost. So if you could give me a quick fist of 4 so I can see where we're at. Okay. All right, good. We're going to do one more for practice. So if you look down at the bottom again, there is another expression. Okay, take about a minute. Fill that in. I know. Will you prop the door open, please, will you?
Can we pop a window?
Yeah, I can do that. Let me get around the room and see how people are doing with this.
How did zero, can you add something with a G and something without a G?
Oh, I was only
Right.
that.
But then you did here, you said zero G plus a G.
Yeah,
You
I
can't do
did.
that.
Okay, that's what I did.
We have to simplify the problem.
Nope, we're not there yet.
Good.
No, because see how this is an and, so that means that it's, that, what's in front of this end?
I don't know.
More, so that's actually coefficient.
Oh, yeah. I got 15.
Okay. Last little bit here. Haley, what were your terms?
N, 4N,
Okay,
negative 7N,
all right,
and negative 1.
awesome. Very good. Like terms, Jonah, would be what?
The like terms would be 1N, 4N, and negative 7N.
N, 4N, negative 7N. Awesome. Let me ask you this. If there is only one constant, is that its own like term?
No, it is not.
No. You have to have more than one for them to be considered like terms. Awesome.
I like it.
Coefficients then, Eric, would be what? What are the numbers in front of your n's?
4,
4, what else?
negative 7.
Negative 7, what else? And what? your constants be? Don't mind.
-1.
-1, very good. Okay, so again, let's go back to that fist to floor after another problem. How are we feeling? A little more confident? Spectacular. Okay. Now we're going to go back up to the top. Now we're going to talk about simplifying expressions.